Doing some rotary table work. I am making a custom fork brace to augment that piece of crap thin aluminium thing on the front forks of the Sabre. That's going to go around this diameter and clamp on on both forks, of course, and holding them very rigid. I can guarantee you that this one's twisting. I can feel it when I ride it and get into a turn. And I'm thinking when I go up in the mountains, I'm trail braking, or at least getting some heavier front brake even on a turn. As I enter a turn, I know these forks are going to twist because this thing feels a little squirrely. It almost feels like it wants to slide out. It ain't sliding out. Incorrect feedback because I'm pretty sure the forks are twisting. These things are just twigs compared to the upside down jobs on modern bikes like the Concourse and so forth. They're just little twigs. These 80s bikes forks were always too small, which is why a lot of guys will completely change the triple tree out for inverteds and put modern forks on, Honda, Kawasaki, whatever they're using, that are the appropriate length, and it really tightens up the suspension. I mean, this thing's already got a monoshock, so you could do some modifications and put a modern version of that in there and tighten up the back end as well. The forks are really the weak point on this thing, so we're going to brace them up. We're going to leave that, of course, because that's what holds the fender in place. It'll be above that. And again, on this diameter here with the aesthetic grooves cut in it. So what I'm doing here is I've already cut the radius, the original radius, on the rotary table. And I'll go over briefly what I am doing right now and then what I have to do. I'll show you what I have to do to cut a duplicate radius over here at the exact right location. That is why I needed those.
Huge. Enormous.
The one I used, the big one. I needed to get an outside dimension from here to there. I needed it accurate. I did that yesterday. Took a couple of samples, averaged them out. Then I took what am I doing? I took one whole diameter. They are slightly different in diameter, so they're only 5 or 8 thou, so I just used one of the two. Subtracted that from that dimension, because that's a half on each side. That gets me the center line. Then I put this on the table just the way you see it. Indicated it square by turning the rotary table to get this thing indicated square. Indicated this, well, it's a little bit more than half, maybe about 55% of a circle here. Circle the radius. Zeroed the DRO and moved over the appropriate amount, which will be center to center on that. The dimension I got was 10.045. That's the outside to outside dimension. Minus 2.480, which is one of the two fork tubes at that widest location. 7.565 center to center. And then leaving in that setup, I just came down with a center drill because I am going to use this to center up. Well, I'll show you. I can't explain it, so I got to show you. And then we're going to cut the radius, put the piece of stock this way, because if you go back here, it'll hit the column and you don't have enough room. So we're essentially going to be advancing on the x-axis, and we're going to leave the y-axis, the y-axis zeroed. Kind of screwed these radiuses up because I couldn't remember what I did on this first one. So all I'm really doing is I made the clamps already. They are thicker because I didn't thin them out yet. It's a long story. I really just want to show you this right now. I'm not going to complicate this. Let me just show you this part. This is the more fun part. Once I get the regular vise back on, maybe I'll show you a little of that. I don't know, but let's go ahead and do that. So now we know where this thing needs to be centered. So that hole there has got to be directly over the center here. Once I center the spindle back up with the rotary table, and I'll show you why. So it's a Morse taper 2 or 3, I can't remember which, but it's got a center in it. So I'm going to put this spring top follower in for now, just get us close. Once we unlock the table, God, I tell you what, freaking cluster today. I think the y-axis is pretty damn close. Yeah, so what I'm doing is I'm using the SDM function. I can set up as many SDMs as I want and always have that center as SDM1. I can come back to it if I need to. Now we got to be on the nut here. This is the thing. especially on this last one. That's dead nut 0 back there. Yeah, we're 0, 0, 0 now. Okay, so I'm in SDM1 now. I'm just gonna go ahead and zero it out. Now that's all I'm gonna do today. I'll show you the rest of this tomorrow or another day because I'm running out of time. But now I'm re-centered basically on the spindles. The center, I should say, of the rotary table. Because we have to work off the center. This took me a while to figure out because I'm just not good at these radii. Usually what I do is because I have to bring it out this way, like I said. I kind of split them this way. We'll bring this part like this. So that center is directly over this hole and the center of the milling machine. That puts the radius that we're going to cut at 0, 0, and then we simply move the x-axis out the appropriate amount, less the cutter width. I'm using a 1/2 inch 2 fluted end mill. It's long enough. Rotating this around. And we end up cutting it out just like this. This particular one was done with a carbide end mill. Because this piece is thinner, I might end up using that carbide again. It cuts this really well. Solid carbide end mill. And we move the part. We don't move the XY, we don't move the table, we move the part. And then we clamp the part down. So as long as that's on center, we're good. Then we don't have to worry about the y-axis at all. Y-axis doesn't matter, it just stays 0. Because we're gonna be doing this once we offset it the appropriate amount. Get the picture? Okay, I wanted to show you some cool stuff. I used a pair of dividers off that mark that we made, you know, from doing the calculation, indicating this radius, moving the appropriate amount like I did yesterday. I showed you that already. With this all indicated in. This was indicated in kind of like you see it right now, but with a different clamping. Well, now we're clamped up for the actual operation and we're ready to go. But I wanted to show you, I used this kind of as a verification, a sanity check, because when I did all these pieces, regardless of which ones they are, you know, the clamps, I did the same thing on all of them. See this line right there? You can kind of barely see it. This was obviously dichromed up. That's 200 thousandths in from the end. That's what this line here represents, is 200 thousandths in from the end. I needed a place to start to put my dividers to make a scribe line appropriate configuration for the radius, which I think was like 1.240. And so when I'd indicated this across yesterday, and then indicated this radius and moved over, theoretically, I should be exactly at 200 thou again because that's what this one was based off of, and we are. So this is kind of cool how that worked out. It's pretty much dead nuts. So that kind of just made me feel all warm and fuzzy inside because we had verification. Numbers are going to be good. Now, I don't know if this space isn't going to be any good, you know, between this guy over here and this. I'm going off of a casting, really, that I don't think the outside of that shock there, where those lines are necessarily machined, or if they're roughly machined. So who knows if this and that are going to line up right. We're just going to have to cut it and be sure. And then all I do is sneak up on it by simply bumping the x-axis that way. And then we come up with our radius. And we'll try it and see how it fits. And we got to do some other clever machining that will be for the 8mm cap bolts, which I do not have. I don't think I have any right now. Oh, we'll figure that out. So I just want to show you that this was actually pretty cool how that worked out. I love it when, you know, you're doing a reference measurement completely different from the way it was originally done, and it works out. I think this is about the best angle I can get yet, so I'm going to leave you there. So 1.240 is our radius, subtract half the cutter, that's a 1/2 inch cutter, 0.250, so we are at 990 as far as going off the x-axis, which I'll move over very close to it. I think the last time I did it I went to 970, started there, and that's what we're going to do on this one too. Lock the table again, and we'll go ahead and lock the Y as well. Why? Why not? I don't think I run this that fast. About 800 RPM. Go 125. Let's try faster than that. Maybe I did go faster. 1,000.
It is only a roughing cut. It will be okay. Calm down.
Yep, that looks good. So 1100. It's screaming because this end here is not supported. I'll file this one under creative fixturing, or maybe fixturing for dummies. I fall squarely in that category. Thank you very much. And I hate that screaming. Well, no, normally I like screaming.
Yes! Yes! Yes!
I crack myself up. It's a lot happier. Beautiful. I'll make a measurement. Okay, trying to get in here with you because I got too much crap over here, but I got this, you know, close as I'm going to get it right now. It's going to require some hand finishing, but excuse me, but now that's nice. Now there's part of that radius exists, so that's why it kind of latches in. That will be gone. Because what we end up having to do, we have to do is mill this. I'm not exactly sure how much yet. To this side here, measuring between the radii and the back edge, come up with a dimension to bring this down to, so it's just shy of halfway across the radius, the diameter rather. And that way the clamps will come in the same way. This will all get done in the regular vise, so I got a crap ton of cleanup to do. And then we will put the Kurt vise back on. I got to tram it in, so it's going to be a little bit before we come back, but for you it shall be a mere few seconds. Told you it'll only be a second or two. First stop we got to do before we get to the fun stuff is we got to bring these cap ends down to the same width as this, which is 560 thou. These are at 1.005. Well, we'll take 200 off this side, flip it over, and then we'll take the balance. All right, we're pretty much cleaned up, although I had to do one quick side mill operation on one of these caps that hadn't fully been done yet. I hadn't developed that radius completely blended in yet. So I did that real quick and they came out real well. Let me show you the other one. It's over here. The radii and the edge there, it's close. Doesn't have to be perfect. What we have to do first is we have to take off material, however, on both of these ends, you know, to essentially bring this down so this distance to here is less and this distance to here is less, but not too much and not too little. And I've been thinking about how to do this. And then I had a kind of an epiphany a little while ago.
Measure them as an assembly, you dummy.
And I said, why couldn't I just clamp this up like this? Now we're going to do these, we have to take the equal amount off of this because it's one piece, but these, we may do them individually and then they'll be committed to that location. This is the side I want up, although there are some scratches on it, unfortunately, from handling. I can buff them out or polish them out. The other side's got some chatter. It's as simple as getting this measurement. This will give me an idea. This is at 2.900 right now. Let me get a snap gauge. We gotta be pretty good on this. Pretty close right there. Let me get my 2 to 3 micrometer this time. Oh, pretty damn close. 2.903 on the mic. I would trust the mic more. 2.903. And what we're going to do with this number is, I don't know, just guess. Throw it out the window. No, we'll take 2.903. I know for certain the curtains are the wrong color. We are going to have to bring this down both sides equally to just under that diameter on the forks. And I know that diameter is 2.480, 2.903. 423 divided by 2. 211 thou will theoretically, off of each side of course, bring us to where this thing is round and it'll just touch the outside edge of that fork tubing, but we want it to clamp. So we need to give it a little clearance. Whoops, and I don't know how much to do on that. I'm thinking maybe 20 thou max. Probably all we need on that to clamp it. I really don't want a big space in here. I would love it if the thing clamped really good on the fork and touched here. But I don't know if I'm going to be able to calculate that. That is not a really reliable surface on those forks. It's again, it's not. I don't think it's machined. It may be just. I don't know what it is. It could be, but it's not very good. I'm going to think about it, but I know I have to take at least 0.2115 off of each half here. With this one at least. We got to test the other one on the other side too. See what the comparo is. And then hopefully it'll be really close. I'll do that off camera, report back my findings. 2.908. The other one's 2.903. So that's not too bad. 5 thou difference. On this clunker, you know, kind of in that rotary table, I mean, that's pretty damn righteous right there. So I'm just going to take and even them out. Who cares if one side's just a few thou different than the other? We'll go 0.217 off each side. That'll give us about 5, 6 thou on a side, maybe 10, 11 total. That should be pretty good. Because these things might, this one in particular, both of them actually, might kind of collapse in a little bit because it's aluminium. And it may achieve what we want it to achieve anyway and bottom these things out while it's clamping on the inside bore. So, okay, I'm clamped, hammered down. I put the hammer down, breaker 1.9. I got a couple of parallels in here. I do have the room between the top of the jaws and the workpiece to take off 217 thou because I got 300 thou. I measured that first. This would be stupid to put all this in and not do that. So I do have enough room, and the parallels are down below the edge of the vise anyway. What these are for, I shall show you in un momento. Alright, we're going to use an indexable end mill. I went ahead and indexed the inserts to a fresh edge. I've used this before. I honestly can't remember how good it was, but I used it to hog out some material on some steel or something. Seems pretty good. Zero the Z-axis. Let's 250 and see how it handled it. Lock the quill. Lemon juice. Oh yeah. Okay, you get the drift. I like the surface finish. It's got a nice pattern to it. I just like the way it looks. It actually did better on the outside here than it did in the center. So it's cutting on both sides of the cutter at least, so the head is fairly trammed, which is not the easiest thing to do on this. You got to do it with shims down there. But yeah, this should be done. I have no way of measuring it. If I was smart, which I'm not, I'd have done a depth mic measurement down to the jaws and then just compared them after cutting or during cutting. That way I could have been sure. But oh well, it's cut now. And I'm out of time for today. I'll do all the caps off camera because you've already seen it in this configuration. It'll be a lot easier to do those. Okay, so I knew this was going to happen. We have some interference issues, but this is just a general representation of how this fits. Maybe a little bit more space than I initially programmed in my stupid brain, but I think it's going to pull in okay. Now the interference lies in two places. In the center here, on top of that original plate. So we need some relief on the underside of this. I want to do some aesthetic machining on this too. I haven't exactly decided on what yet. It's going to be, I think, with a ball mill. Maybe just cut radius here, underneath here, on the top, and certainly one back here to make this clearance happen. Move that out of the way. Whoops, and drop a workpiece. Ichabod, I do not understand why you're so stressed. And as far as this one goes, I can't get it to go down anymore because where it's hitting is right there. You know, with this high spot where it ramps up. Which again, I knew was going to happen, but I didn't want to go any thinner. So I just need to mark this, provide some relief on the bottom for that, probably with a ball mill or something. And then once we can get these things to lay flat, I'll show you it back again. So I'm going to do all that off camera because, well, it's pretty boring stuff. When we come back, I'll show you the end result as far as up to this stage. Not the end result because we don't have any holes yet, but we're doing that shortly. Ichabod's kind of freaked out by the weather right now, so that's why he's pacing back and forth. I gave him a quarter of one of his gabapentins for his hip pain, so it might calm him down a little bit. That's why he's doing what he's doing, poor thing. We had a wicked rainstorm last week, and I think it absolutely damaged his psychological well-being. I mean, he was the most freaked out I've ever seen. Now, this is what I came up with. I took off a lot more than I really wanted to, or I needed to, though, unfortunately, and I kind of have worked this out a little bit by hand, too. I used the side cutter on that indexable end mill, which is probably 30 degrees off the vertical. And we got plenty of clearance now. You're not going to see it anyway. My only concern was depth or protrusion of the thread. We got plenty of threads going in there. We're not going to be able to go really too much farther than past the radius anyway here, so that's a good, what, ½ inch? 13 mil or so. We're fine. And they fit good. It is like, whoops, well, not like that. Like this. They fit very well. Now, if you're concerned about, I was just thinking about this too, up here where the bushings are, I wouldn't fret too much. Those bushings are kind of a little bit wore out. I mean, they're not terrible, but they are a little bit. If it tightens it up a little bit, all the better. And I think it'll be fine. I mean, if we put it on and it binds up the fork, excuse me, I got gas, we will not use it. It's a fun project nonetheless. So I'm going to figure out what kind of operation I need to do for relieving that center section for the big piece. It shouldn't be anywhere near as aggressive as this. All right, I just had to relieve 100 thou. I probably didn't need to go all the way through, but I ended up cutting the wrong side. I meant to just cut the back and bring it up to the edge here so you wouldn't see a line in the front, but I screwed up and cut from this side instead, like an idiot. And it's going to be okay. I mean, it looks all right. I might just run like a 45-degree chamfer tool in the mill down this thing and kind of dress it up. I'm not sure if I'll do any other aesthetics. I'm not going to do that anyway until the holes are done. It clears just fine. So if we take one of the caps, which are also relieved, take the appropriate one for the appropriate spot. we're pretty much right where we need to be. I'm going to do this one over here because it's very difficult to show you the other one. Just the camera angle. I don't have a lot of room right now, but if you put this in here, you can see we've got pretty good looking joint there. Joints, dude! These are just a little bit away from each other. Actually, it's better because now that there's clearance in there, I can get it, clearance, I can get it really close to it. And that seam is a lot less, so that's pretty much how I designed it. And again, we can take more off this backside if necessary. If you squeeze this, that's pretty tight. But I can already feel it touching. So we're definitely going to have to take some off the back, but I'd rather have it too much than too little. Because I can squeeze this in and this thing is a little loose still, but it's barely. So that's good. I mean, that's fine with me. I mean, I can always put this back in and just mill it down an equal amount up to that point. Maybe up to here, it's not going to make any difference if we want to ultimately keep it as round as possible. And I may do that. Those operations would not affect the position of the holes for the cap bolts coming in the back side. Well, actually coming in the front side. Through here, we're going to counterbore a certain amount in. We're going to have to counterbore in a radius here, and then we'll drill and tap. This is going to be some figuring, so what I got to do is I got to clean up all the mess from this operation. I got chips everywhere again. And then start figuring out what we're going to do for setup. All right, we're all set up here, and I want to show you what we got going on. I made one mistake as far as my order of operations. I should not have cut that relief on the back of this before I did these holes. Set up the way it is, I would like to really just put one, 2, 3 block in the center. Can't do that because it'll bow this thing. I have the parallels, different ones, but parallels nonetheless, sticking out, clamped in the vise as well, so we can clamp this again, because we're going to end up having to go straight down in here, straight through, and then these are clearance holes for the cap bolts. I would have liked to have put the cap bolts on the back side, and unfortunately, because of the amount of clearance that I had to relieve on the backs of these guys here, there's no way to do that because I got nothing to counterbore into on one side. So we have to put the threads on this side. We got no choice. I can't fixture these all together. I would have liked to have fixtured them together, even one side at a time, but the part is too high, and therefore there's no vise left. If the vise was twice as high, we could have done that, but it ain't. So we're going to do it this way. It's kind of a, I wouldn't say a crappy setup. It'll work, but because I don't have a knee mill, I have to set my maximum height for the drills that I'm going to use. I can get down to center and things like that, but when I go to counterbore those, I can't reach it in a collet, and I can't use a long end mill because what's going to happen is it'll wobble around. So we're going to have to violate the machinist's creed, basically, and probably put a different chuck in and put a end mill in a chuck.
End mill and a chuck.
Oh no.
No! God, please, no! No!
These holes have to be clearance holes for M8. Start picking up centers and picking up edges. Since I milled both of these edges in the last operation and the cap's the same, I know that my references are good. The dimensions are slightly different on each side, but not by more than about 5 thou. We're going to go ahead and use the SDM function again, and we'll do SDM 1, 2, 3, and 4. Start off a little slower. Like that. Okay. There we go. Okay, I'm over on SDM100 and I've got a 10.5 millimeter end mill in here. I know that's not big enough, but it's going to be close. And we are going to go down till we get a full circle. And then we have to go 312, 310 thou below that. Because I want to go to the close to the full depth that this cap bolt is going to be sitting in the head of it. I measured one of the typical ones that I have. I got a lunch date today. I got to hurry up with a couple of guys, as far as you know. Should be pretty good right there. I use a fine feed. It's a sharp end mill, so I know it's not supposed to be used in a drill shock.
This is another common mistake I see.
I know, I changed chucks over to the big end. I know that, but I don't have, I'd have to lower the head and reset everything, and I'm not doing that. These one on the ends will not be as visible because they're on a radius. I wonder if we can get away with only going half. Let me see how it looks. Figuring this shit out as I go. There's 100. How's that look? That's not bad. You know, we might just do this. Just do 187 instead. Here we are. Yeah, that's pretty good looking. I think we'll do that. If a little bit of the bolts showing, we got a lot more material in here now. And it's going to come out a little bit bigger diameter, you know. Picture this, you know, something like that. That's not bad. I think that'll be pretty good. So like about half the head of this thing going to be up like that. I think that actually will look nice. I'll finish this up later off camera. We'll get the other ones done. All right, so I'd like to show you what I'm considering the finished product. It's all installed, all tightened up. Let me go over some background here. The initial mock-up and fitment showed this a little bit on the loose side. It was tighter on the right side than it was on the left. You could actually wiggle this thing up and down and it would move on the left. And that is with the clamps all done up. So in other words, the clamp cap part is meeting up against the body part. So I took it off, and I think I mentioned I was going to do this earlier anyway. I took 7 thou off this mating surface up to about here on both sides, not across the whole thing. And then I took 7 thou off the cap part, so a total of 14. And that gives it a good clamping purchase on both sides. So that solved that. So the next thing after that, I just did a bunch of deburring and things like that, and I decided to do some cosmetic work on it. So I did some layout, and I used a ball mill and milled these radii in here, radiuses, and I think that really kind of accentuates the look. It makes it look a little less homemade, in my opinion. Now, as far as the bolts go, I originally just got some black oxide. These are 12.9. I didn't need that strong bolts, but you know, M8 cap bolts actually. And I got those at Hardware yesterday. I put them in vinegar overnight and stripped the black oxide coating off. And then brought them to the appropriate length for each location. Obviously this one's going to be longer than this one. I'm really glad I didn't go down the full depth on this, because when I realized that this is obviously a lot further forward than this spot. So going 187 or 3/16 was perfect on that. Now, I had to machine the heads down diameter-wise on all the cap bolts so they would fit inside these holes. And in doing that, plus stripping off the black oxide, I went ahead and zinced them in my home zinc kit. So that they're all zinced up. Unfortunately, the zinc kit does not get inside the hex very well, so I'll have to touch that up with some silver paint. Otherwise, that will rust immediately inside there. But it will seal it off as long as you clean it really good with a Q-tip and some alcohol, or brake clean first and then just dab little testers. I use the testers model paint silver. You'll never notice it, and it'll keep that from rusting at least for a while. But it is really solid. I took it off the center stand and bounced on it. It doesn't clamp up the front end at all. I think it's going to be a good addition to the handling characteristics of this bike. to beef this up a little bit, because this is pretty flimsy underneath there. I know it was twisting. I could feel it. I think it's going to be good, so we'll see what happens with it, but I just wanted to bring you along for the ride on these machining operations, in particular this one, which was, pretty in-depth. There was a lot of operations on this, because, I'm winging it, basically. But I think it came out fantastic.